Preet, you are muted.
Yep, so we'll wait a couple of minutes for audience to, fill up the room, and then we'll get started. We'll wait for another 1 minute. At 7:03, we'll get started. I hope the audience will fill up the room. We already have a bunch of them in the room. Okay, 2 minutes over. Good morning, everyone. Good evening, and probably late evening for many of our participants in the Deep South, APAC region. So it's true pleasure and honor to be part of this exciting discussion. And to get started with, I would like to first thanks a big thanks to IEEE Circuit and System Society, CAS Society, for giving us this opportunity to run this webinar today. And it's a true pleasure and honor for me to be to be the moderator for the session today. To with us joining are Steve Sumu Kang, who is Distinguished Professor of Emirates and Research Professor at UC Santa Cruz, Chancellor Emirates at UC McLean, President Emirates at KSAT, and many more big achievements. Further, next is joining us Lejana. She's Professor, School of Engineering Science, Simon Fraser University, Canada. And it's early morning for her, if I'm not wrong, around 5:30 a.m. So a big thanks and huge respect to Lujana, accepting the invite and accommodating our request to be here early in morning. But you look as fresh as one could be. So thank you so much, being here. Let me move forward. Again, a big, I would say huge achievements in terms of technology, technical trends by her. And last but not the least, Mikhail, who is professor and head Department of Information Technologies, and Jinglion University, Poland. So thank you so much, sir, for joining us. And my name is Preet Yadav. I'm chair for IEEE Circuit and System Society, CAS Delhi chapter. So we have expert joining us from different time zones, and these all, big shots of this technical word, they contributed to Circuit and System Society in past. And I'll be not wrong, we might have few of our participants who might not have born even, when all these stalwarts might have done their, their engineering education and big achievements in the technology sphere. Okay. So with this quick short introduction, the way we would like to run today's discussion is we'll start with a quick introduction by each of the expert today, and various domain they have worked so far, and that would be about 3 to 5 minutes each to start. post that, I'll have a couple of round of questions to these each experts from me. And at the end, we have kept a slot wherein we'll do a Q&A, from the audience with our experts. So without any further ado, we can start in any order, and I can go the order I see the pictures on my screen. So I certainly see my name on the top, and I am not the panelist today. I'm a facilitator for the session. And the next in line, I see Steve Sumu Kang. So Steve, request a brief introduction of yours. All the great work you have done so far in terms of technologies affair. And we'll move to
Uh,
Majak and finally to Lachana. Over to you, Steve. Thank you.
Thank you, Preet. Glad to be here for panel discussion. I am Steve Kang. My specialty has been in microelectronics, but my education was in nonlinear circuit theory in the beginning, and got into CMOS technology, and worked at AT&T Bell Labs. And there I developed a 32-bit microprocessor, Belmac 32, which was designated as a new IEEE milestone this year, after almost 50 years. And then after that, I moved to University of Illinois, Urbana-Champaign to teach. So I had a great pleasure being a professor, working with bright minds. Benefited a lot from my own students. And then I moved to University of California System, and been at Santa Cruz since January 2001. And along the way, I served as a Dean of Engineering, and then the Chancellor of UC Merced, the youngest campus of UC System. And then I was also president of KAIST in Korea. I originated from Korea. And then after retirement, I've been continuing as a research professor, working on the neuromorphic computing using memristor and hybrid CMOS and memristor. And memristor, by the way, was the topic I worked on at Berkeley when I was a graduate student with Leon Chua. That time, really didn't know what use of memristor was. So I did even ask Professor Chua at that time that will there be job if I work on this particular topic? To make a long story short, that was in early 1970s. 2008, HP, Stan Williams and his group members created a solid-state memristor, and ever since, the field has been very exciting. So 2008, after their Nature paper publication, the total number of papers published in that year was 8. And by 2020, it grew to almost 2,000 per year. So that indicates the really booming nature of this field. So I'm very excited. And I am excited to collaborate with many bright minds in this field. So that's all. Thank you.
Thank you so much, Steve, for your kind introduction, and you were candid enough to, shorten it up in terms of all the, great work on your name. So next on my screen, I see Majak. Why don't you go next and, have a round of introduction on all the great work you have done so far?
Thank you, Preet. I'm grateful for this invitation, and thank you for organizing this special kind of event. I work currently, and I started my scientific work, and I did my education also mostly in Poland. For half of my career, I was with the engineering school, and already 21 years ago, I moved to a classical university, which had never had engineering in the past, although the university is 650 years old. So with me, we sort of started engineering at Jagiellonian University, quite famous institution in Europe and especially in my country. And so I had the pleasure to meet many people around the globe. So I also have experience working in different laboratories. Coincidence that I at one of the conferences, ISCAS conferences, I met Professor Leon Chua as well, and which resulted in my postdoc position in Berkeley in the 90s. And well, I had opportunities to work also in different places in Japan and in Switzerland. So quite wide experience in different countries and different institutions. My beginning was associated with Professor Leon Chu. Obviously started with nonlinear circuits and chaos in particular, and applications of chaos in communications. But I did also many other things. In recent years, I mainly work on EDA topics about designing or inventing new architectures for integrated circuits. As you know, we entered the era where integrated circuits go in three-dimensional structures. So this is particularly interesting for future developments. It touches also memristors at some point, as Steve mentioned a minute ago. But in my career in Jagiellonian University, I was department chair, and in information technologies, so we did also in my group many other things in pattern recognition and applications of pattern recognition in medical diagnostics. Well, I can say my latest developments with my colleagues and collaborators. We very recently published a book about pattern recognition in Springer. So that's I'm still teaching and still doing research. Thank you.
Wow, that's so amazing. You are still actively contributing to research, and the memristor story is still ongoing. There are more and more new things happening around. And as like Steve, glad you are also associated. So let me go to the only diverse candidate we have on the call today, and who woke up and I assume around 4:30 a.m. probably, Jana, your time, and being here with us. So first of all, a very kind welcome and huge regards to you for making it up for us early in the morning. And next is you. So I would request if you can briefly introduce yourself, please.
Thank you very much, Preet, for introducing me and for inviting me for this. It is 5:30, 5:45, so it's better, but it is early. And I'm known for being a night person. So yes, it was a little bit of an effort. So thank you.
Thanks for completing the request.
Thank you. Well, I came to US as a student, and so that really changed my life very much. And then I moved to Canada, but I come from Yugoslavia. The country doesn't exist anymore, but I'm from Serbia. And I came to US as a Fulbright scholar. Over there, I finished my bachelor degree in power engineering. And when I came to US, I really came to do classical nonlinear circuit theory. So I was a student of Professor Alan Wilson, and I was first at Syracuse University and then at UCLA. At Syracuse University, I worked with two people who are quite known for some old-timers in circuit theory, Balabanian and Professor Bickert. And so I really have my life for theory. And so I always did theory all my life. And I actually wanted to study mathematics, but it didn't happen. But I do apply a lot of math and a lot of nonlinear circuits theory to what I do in terms of research and my work with students. So I graduated from UCLA, and then I had a job with Bell Communications, actually with Bell Labs. And in Bell Labs, I worked on computer-aided design tools. And it was a very nice fit because we really applied some of the notions and some of the theory we developed for nonlinear circuits, specifically circuits with transistors, both BJTs and MOSFETs. And we tried to improve circuit simulator. And at that time, the circuit simulator in Bell Labs was called Advice. And it was actually brought from Berkeley by Larry Nagel, who was a student of Donald Pedersen, and he actually invented SPICE, simulation program with integrated circuits emphasis. That's an acronym. It's not a spice in the kitchen, but you probably all use SPICE during your undergraduate studies and graduate studies in order to analyze circuits. And so we worked on a tool. So I work on numerical methods for improving convergence in a circuit simulator, such as Advice. And it was a really different kind of beast because when you have a circuit simulator to be used in industry, you really have to work with models. And these are real models that reflect the fabrication and the properties of the fabrication lines in companies. And in this case, it was Bell Labs. I was unmanageable, they told me, because I really wanted to do research and I was in a development team. So after a while, I went to Bell Communications Research, worked a little bit longer on this continuation and homotopy methods for improving circuit simulation and to improve convergence and to improve performance. And then because of the company directions, I actually moved into analysis of traffic. And I have been working on this ever since. So I have like 3 different lives. As a student, I did power engineering, generators and motors. Then as a graduate student, I did nonlinear circuits. And then now that I have been here in Canada for the last 27 years, I've been working on communication networks. And so I still work and I still teach. I didn't retire. I still have students. I do travel quite a bit, and this is a nice part of our job. But as currently, I'm teaching a second order circuits course, and I've been teaching circuits all my life. So this is quite interesting. New generations, but I still teach basic circuit theory course to the second year students, and currently I have 158 of them. We do lectures and we do labs and we do tutorials. So it's like going back in time. And I moved to Canada in 98 because of the job, because I was looking for academic position after spending some time in industry. And I stayed. I've been very active with IEEE on various levels. At the beginning, my starting with the volunteering job was really with Circuits and Systems Society. I always considered this as my home society, and sort of I would always say my first love. And it was introduction to the volunteering job that I enjoy very much, because for me it's another dimension to my life. So in addition to having a job and doing my duties as a professor and a teacher and a researcher within university, I also volunteer a lot for IEEE, and I find it very rewarding. And I have only been always very nicely treated. I have 2 societies. My home society at the very beginning was Circuits and Systems Society, and now I'm very much involved with System and Cybernetic Society. And even that's over. So I was a president of CASS, but I was also a president of SMC Society. And then I was a director for Division 10. This is really a combination of a variety of societies with the same team, such as Circuits and Systems Society, Electron Devices, Solid State Circuit Society. So I think there were 10 of those. And I also work on various committees. And as I mentioned, I still teach, and it happened that this semester I am teaching basic circuits. So that's all from me.
Thank you so much, Lejana, and so glad to know you still have 100+ students associated with you. That's so amazing.
They are undergrads. They are not my grad. I wish they were my grad students. They're undergrads. They're undergraduate students, second year.
Certainly, but you're helping them to shape up their careers. So good to hear about that. Okay, so with this great introduction by each of the panelists today, and all put together, we have more than 200 years of experience on this call, you know. So, glad moment for me to, interact with you all guys. So let me start with the first level of, question with each one of you. And I would like to go in reverse order this time. We'll start with Lajana. And Lajana, and this is something, which I assume most of the audience would like to know, is that what all good interactions you have done so far all these years being part of IEEE, as you mentioned, you are being associated with two of the society and you call CASS society as your home. That really, makes each one of us pleased being, and I would say proud moment for us, each one of being a member of. So help us to, know your major interactions and milestones in general related to IEEE and specifically, to the Circuit and System Society. And we'll be happy to know about the other sister society, the second society you're being associated with.
Thank you, Preet. I think when I was a president, we did several things. It was a long time ago. I was a president in 2007. So at that time, I think the society was, as always, financially wealthy. So we could really afford doing a variety of initiatives. And I think one was to actually do initiatives for major projects. And so I think that continued. And the other one was introducing young professionals and graduate students to the leadership of the society. So at that time, we worked with bylaws in order to enable young professionals to be part of the board of governors, and I think that has also continued. But in general, I think when I was a president, it was 1 year term, so it was really that 1 year really passed very fast. At that time, we had executive director, so I worked with, her name was Heidi Zaza. It is Heidi Zaza. And so I worked very closely with her in order to run the society, and I'm very much hands-on. So literally, we would meet every Monday in order to make a plan for the week. And I think it was when I started to be a president, I was quite concerned whether I can do it or not. And I presume many people do that when you get a position. You sort of wonder, can I really do that or not? And before me, there was another lady, Ellen Yoffa. She was a president. She was the first female president for Circuits and Systems Society. And I really had a very great leader before me to learn. And the year went by very fast with ups and downs. It's not a smooth ride. But I think my major that I remember now, looking back at 2007, was introducing young professionals to the governance of the society and also having initiatives so that people can apply for funding. And CAS Society was always very close to chapters. And at that time, we also pay attention to have initiatives for chapters. And if you write a report at the end of the year, you would get some funding in order to run seminars. And I think the society still do that, which is really very important because sometimes when you are president and you're a member of the board of governors, you get disconnected from the trenches. I now see that a lot of people were probably not known who was on the board of governors and who was the president. So it's very important to keep connection with the base. And so some of these initiatives really help us be connected with the chapters and student branch chapters. And for the other society, SMC society is a little bit different. The structure is different. While in CAS society at that time, now bylaws have changed, but at that time, presidency was 1 year. So the president-elect 1 year, president 1 year, and a past president. And they still invite you to do a variety of services, such as serving on various committees, awards committees, fellows committee. But in SMC society, that stands for System, Men and Cybernetics, actually the commitment is much longer. It's all 2 years, so we have 1 year president-elect, 2 years president, 2 years junior past president, and 2 years senior past president. So it's a 7 years commitment. So it's a little bit smoother ride. You have more time to actually work on your initiatives and to implement them. And it's a society belongs to a different division. So it's a division 10, while Circuits and Systems Society is in division 1. And so I had a different experience. It was completely volunteer society at that time. And I had great volunteers in both cases, even in CAS and in SMC to help me. So you don't work alone as a president. You actually have a team. And your performance really depends on the team. So if your team is good, then you look good. So that's all from me. I
Thank you so
presume I
much.
answered your question, Preet, right?
Yeah, you answered it pretty well, and impressive stint of you. And as you said, the commitment is not for a tenure, okay? It is before that, after that, and still, fulfilling all those good work for the society, even after you moved out of that positions. So yeah, once a president is always a president, and we look forward to your services to this whole technical community. Thank you so much. Okay, so let me move back. As I said, we'll go in the reverse order. Let me move back to Jack, and I posed you the same question. Help us to know all of our participant today that your association, your contributions with IEEE in general, and in particularly to circuit and system society, touching back the history, the major things which came across during your tenure and, probably before your tenure. Yeah, thank you.
Okay, thank you. Well, maybe I will start, with my first involvement, becoming member of IEEE, which was 40 years ago or so. So, and at that time, the main reason for me for joining IEEE was to get access to publications. In those days, we had publications in volumes on paper, and they were, well, not so easily available. So availability of scientific papers was the major reason for me to join the IEEE. And as a PhD student, and just after completing my PhD, I had opportunities to join several conferences, and I realized that one of the important things was networking. So that was for IEEE involvement. I think ever since it remains as a very, very important factor, is meeting people from different countries, different universities, different cultures, different industries, and this brought me actually my first function in CASS Society. I was invited by Professor Tony Davies, who unfortunately passed away, is not anymore among us. But Tony at one of the conferences told me, "Oh, well, why don't you get involved as representative, for Region 8?" So Region 8 covered Europe, Middle East, Africa, so quite wide area geographically. So I became a member of the Board of Governors at that time, and ever since, I went through different steps in the society. I was lucky, as Liliana already mentioned, the name of Ellen Joffa and Liliana herself were the predecessors for me, two fantastic presidents that introduced me into our higher level governance. And I became finally the president just after Liliana in 2008. So I think among the achievements that I am very proud of, I think it was, although it was started by Liliana and probably even Ellen as well, the first meeting of young professionals and also women in CAS was, I think, in Seattle, at ISCAS in Seattle, where I had the pleasure of being the society president. But I think I consider one of my best experiences on the in the CAS Society was organizing the conferences in Latin America. Latin America was looking at our conferences like ISCAS. There were very few members from that region coming to our conferences. Some of the countries are less advantaged, you know, they had less money, so they couldn't travel to Europe or to the US. So we decided to bring the conference to them. So we created. Obviously, this was not only my initiative. There were great volunteers in Latin America that brought this idea of organizing Latin American Symposium on Circuits and Systems, and it came into living. And I think that was one of the big achievements for which I gave my very strong support. And the conference still exists, and we have big involvement of people from different countries in Region 9, as we say. I consider this, you know, this widening the international content of our society was really something very important. And one more thing, which I think for myself was a big step forward, was I had the pleasure of, you know, leading the Circuits and Systems magazine when it was born. You know, before we had the Circuits and Systems Society newsletter, which was very nice newsletter, but it was not. At some point, you know, the governance of the society decided that it would be good to convert it into something more significant, and we created the Circuits and Systems magazine. And I had the great pleasure of being editor-in-chief for early years of the magazine. Well, I did many different things. As mentioned, I was CAS president. Later, I was elected Division 1 director, so also member of the board of directors of IEEE. I did many things in different places in IEEE, in Fellows Committee, in Conferences Committee, and many other smaller and bigger groups of volunteers that make this huge number of interesting things happen in IEEE. So it's a great pleasure. I am still involved also in other societies. I'm member of Computer Society. Within Computer Society, we have the action which is called Rebooting Computing, for which I contributed several years of my volunteering as well. And this initiative is still running. In recent years, I was involved also in a little bit, you know, forward-looking of what IEEE and CAS will become. And last year I was chairing what is called the New Initiatives Committee within IEEE, which is across everything, and well, a body which is supporting the great ideas that people in IEEE have for developing new creations and new ideas, new initiatives. So maybe I will stop here because probably I'm using all my time already. Thank you.
Thank you so much. Thank you so much, Mikhail. This is so kind of you for all the great contributions you have done so far. Starting with the publications you mentioned, and then getting IEEE CAS to Latin America, as you said, because all those conferences, they give a, a new, I would say, hopes and new start to the region, and finally starting the CAS magazine and, being the editor-in-chief there. So I think all those good initiatives are still continuing. I still see ECCAS getting rotated in different parts of the world, and
Last
CAS,
cast.
last
It's
CAS, oh
not
sorry, yeah, and CAS magazine, I think, is one of the favorite of all category of members, being the students, undergraduate students, to YPs, to senior members and life member. Each one of them look forward to this magazine to get latest and greatest updates of all the good things happening across CAS. Okay, so let me go to Steve, the last but not the least. Steve, you have again a rich history with IEEE in particular, and certainly with Circuit System Society. So kindly share your viewpoint, your engagement with the society and IEEE in general, and the major highlights.
Thank you. Yes. So as I said before, my initial start was in nonlinear circuit theory under the advising of Leon Chua and Charles Tissot at UC Berkeley. And I remember back in 1974, there was a ISCAS conference in San Francisco. Chairman was Sanjit Mitra, Professor Sanjit Mitra. And the technical program was headed by Leon Chua. So Professor Chua at that time asked me to get involved. That's how I got involved with the Circuit and System Society back in 74. And then I became assistant professor at Rutgers in 1975 before moving to AT&T Bell Labs in 1977. So during those 2 years, I was involved in Princeton chapter. B.D. Liu was a chapter chairman of a Circuit and System Society. So I started, my involvement with the Circuit and System Society at that time. While at the Bell Labs, I worked on, in the beginning, in Homedale network division, private network design project. So that was a satellite-based the private network design optimization, and that was interesting. My training in nonlinear circuit theory and optimization and all this mathematical thing became very useful at that time. So how do you optimize multi-node satellite-based private network for all the corporations? And turns out to be a very non-linear optimization problem, and I had to learn about traffic theory, which we never learned in university. So I had to study traffic theory and this Erlang as a measurement unit and all that. But when you formulate this problem, it turns out was a Lagrangian based nonlinear problem. So I was able to decompose into 3-node network, coupled 3-node network, and did this optimization, which proved actually that heuristic network design practice in AT&T for decades was really optimal. So I sort of proved that the 3-node network design is optimal in that sense. So that was very satisfying and rewarding. And in fact, I presented this paper at Midwest Symposium in Philadelphia, from which I got the Best Paper Award. So that was sort of interesting. And then I moved to after 1 year to Murray Hill to get involved in CMOS VLSI design. And again, during my academic training at Berkeley, I didn't really study CMOS or device. So I had to learn a lot of things. In fact, the level for the in-hour course on devices, actually teachers came from Columbia University to teach during the working hours. And a lot of things I learned, processing also I learned from scratch. that was tremendously helpful for my involvement in not only Circuit and System Society, but also Solid State Circuit Society, Electron Device Society, and later the Reliability Society, and then also Photonics Technology Society, because when I, after the labs, microprocessor development, when I moved to University of Illinois at Urbana-Champaign, I was involved in also the Engineering Research Center, which is emphasizing optical interconnect for high performance systems. So again, I had to study photonics technology, for which I got involved in Photonics Technology Society. And also one of the research topic was on the VLSI reliability. In fact, there was a professor expert in the device physics, and he was studying hot carrier reliability issue, but industry didn't know how to use his result. So the department head came to me and asked for my help. So I suggested actually embed such a phenomena, device physics, into transistor model, which we did jointly with my former student, Yusuf Leblebitsi. So we got involved in reliability issues and the ESD. So that's how I also got involved in the Reliability Society, which was very, very rewarding. So then while at Illinois, I was involved in, more actively with the Circuit and System Society, Board of Governors and the Secretary and Treasurer, President-elect, President in 1991, during which we did the ISCAS conference in Singapore. So when I returned last Singapore ISCAS was almost after 30 years, so it was quite like reminiscent of the past history. And then during that year, we also made a visit to China. I led the delegation to visit China, Beijing, and other places to organize a talk. And then later we also visited Argentina for IEEE, tour group and all that. And then also, with my background, I saw the need for emerging importance of VLSI systems. So, I proposed, and then after presidency, started as editor-in-chief to create a transaction on VLSI system integration. So that's how I got involved in not only Circuit and System Society, Solid State Society, Electron Device Society, Reliability Society, technical, also Photonics Technology Society. For those, I served as a distinguished lecturer as well as a fellow committee and also other editorial board. But overall, I served on the proceedings of the IEEE editorial board for several years. I think 8 years I served, and then proposed many special issues like interconnects, thermal engineering, and that sort of thing. So my experience assured me that interdisciplinary engineering through Circuit and System Society, not only theory, but working with the device folks and the system folks, the Circuit and System Society can really play important role putting all these things together. So I'm very grateful for many visionary folks in CAS Society colleagues, which I had a great pleasure learning from and working together, and also bright minds, future generation guiding doctoral students and all that. So many patents and various publications. I owe a great deal to my own graduate students and colleagues. Yeah. That's all.
Thank you so much, Steve. And so good to know your association. Apart from CAS, EDS, Photonic, and many other good societies, and I don't think so. I have come across anyone else who has
We lost you, Prithvi. Don't hear you.
Mhm. Did we lose him?
It seems.
Looks like.
So maybe it's about time to ask audience to start asking questions. I think we need to hear from them. And how do we open that?
There are a couple of questions in the chat. So if you open the chat on the bottom, I can see people saying hello. I also see a question from my good friend Wolfgang Mattis, which is a difficult question. His question is, what is the status of classical linear and nonlinear circuit theory in today's CAS society?
That's a tough one, actually.
Yeah, it's a difficult and emotional one, I think.
Yeah, so I give you a very simple example. For instance, often think that is an old theory, but really fundamental. And as I indicated earlier, that the training and the background in theory and the mathematical preparation helped me to do really a very complex nonlinear circuit design, network design, even at AT&T Bell Labs. That was very, very satisfying indeed. The another example I can quote is I was very naive, new in VLSI design at Bell Labs, and when you do the chip design, you care very much about the power dissipation. And in CMOS design, the standard formula for power dissipation is like a capacitance, and then V voltage square, and then frequency. So power is equal to really capacitance multiplied by power supply voltage VDD, and the delta V, the voltage swing, and then frequency. And that was used for practical circuit design. And then I was questioning, is the capacitance really constant? And turns out capacitance is voltage dependent in micro chips integrated circuit. And what about the voltage swing? You don't really get full swing in many, many cases. So delta V is not VDD. So, VDD square is not correct. Frequency, yeah, that's correct. So I had to apply the basic circuit theory and create a circuit module which can be used in circuit simulation like SPICE. At the time, as Liana mentioned, in AT&T Bell Labs was advice. Larry Nagel was there. So I created a circuit module which can be embedded into advice or SPICE. And then you get precise power dissipation, including all the variation in capacitance and variation in voltage swing and all that, which was enormously helpful. So we used for precise evaluation of power dissipation in integrated circuit. So I published in Solid State Circuit Journal, and it has a few hundred citation of that work. And I think a CAD industry also adopted that approach to have a precise power calculation. So that's a sort of a simple two examples.
Thank you so much, Steve. That is quite inspiring. So let me pose the same question to Jack. What was the main motivation for you to being in circuit systems, being in electronics or semiconductor industry? Because things are much different than what we see now. And what motivated you? What encouraged you to be part of this?
Yeah, as I already mentioned, my initial actually I studied my major was microelectronics at that time. It was not the same microelectronics as we have now, but in particular, I was designing oscillating circuits, and so for that, without theory, and you couldn't go far. Really, theory was needed, and And in those days, we actually had a significant number of courses during my studies in circuit theory and nonlinear circuits, and it was one of the very important subjects. What I observe nowadays that they still are important, but they are, the number of hours given for teaching is shrinking. I know that in some places, well, the shrinkage is really very, very strong. And in many places, people consider that simulation can, or excellent simulation tools can replace knowledge of theory, which is not true in my opinion. No. So I strongly believe that theory is needed there. And well, if you think about motivation of well, what we call the STEM education was important for me. My father was also a scientist, so I had good example and very exciting examples. So he was author of more than 30 patents, and and well, I was always enjoying sitting with him and asking millions of questions of different kinds. So from my early days, I did that. Well, my older brother was very different. He became an architect, so he went into a little bit more artistic lines. So in the same family, we followed different paths. But I think at some point I started, I got involved in building radios, and I built my first vacuum tube amplifier for listening to vinyl discs that we had at home. So this depends on personality, but certainly that was my in my itinerary in electronics started early during my school time, and later just became wider and wider. And well, my own two sons work both in IT, not really in electronics, but IT and networks and this kind of things. So they are very near as well, but didn't follow my footsteps exactly. So maybe that's I don't know if it answers your question, but there's a little bit of my personal story.
That is quite inspiring for each one of us. Thank you so much, sharing us those, personal achievements and the good deeds you guys have done for this noble service, I would say, to the society. And now let me come to the last legend, ever smiling. So please, share. I still recall 100% students. Wow, still. So please share, all the, and probably this could be the last question. We only have 6 minutes left. That why semiconductors, or I would say, why semiconductors or electronics now in all those decades? So what was it who motivated you, and what is that inspiration who still keep you, going, working in circuit systems or electronics in general?
You're asking me, Preet, correct?
That's right, ma'am.
Okay, well, I was thinking about how to answer Wolfgang's question. I still get over summer students who come to my lab through a certain program in Canada. And they work on homotopies and continuation methods, because we propose, and I usually propose 2 topics. One is in applying machine learning to analysis of traffic and anomalies. That's what I do at university now. But I also have another topic. The other topic is how can you actually work on certain small implementations of continuation and homotopy methods in order to solve difficult circuits. And what are difficult circuits? These are circuits that have multiple operating points. And I still get students, sometimes from IIT in India, actually, who come and visit me for 12 weeks. And they actually contribute and, they learn about nonlinear circuits. And something else I want to bring up, even though it might be just a mental exercise, and some people are still interested in solving some open problems in nonlinear circuits. And one open problem is synthesis of resistive networks. It was never really solved.
Yeah.
So it's, I know that some people in control theory who are retired now, I think it was maybe Kalman, I heard that they are actually working on it. And I think that with AI, we might really be able to solve the problem. So for the younger generations, the resistive network problem is a problem when you are given a matrix and you have to synthesize a circuit. Because in the old days, we actually had two kinds of courses, analysis and synthesis. Synthesis, forgotten. But they were, when I came to UCLA, we had analysis and synthesis and digital filters design. So it was really a very strong program. And I also brought some background from back home, where the circuit theory was very much a field that was of interest to professors and the researchers. So the synthesis problem of resistive networks is still open problem. So even if it's just a mental exercise, I think it's still a very interesting problem. And with new technologies and new achievements in AI and machine learning, it might well be that we are going to solve it. And I hope that some of the new generations would be interested to do that. So that's what I wanted to add before I forget what I wanted to say.
Yeah, to add to that, we these days talk about a lot about AI, and then the machine learning and AI acceleration, etc. Now, before people used to say that, oh, everything is a software, right? Everything can be done by software. But I've been always saying that engine is still hardware, for which the circuit and system people can contribute a lot. So earlier, Maciek also mentioned memristor. So let's just get a look at the memristor. Leon proposed memristor as a concept in 1971. These days, in neuromorphic computing, which is computing mimicking brain operation, it's a rely on memristor a lot. Huge matrix multiplication. Rather than digital way, you can do it in analog way by applying Ohm's law and the Kirchhoff's law. So summation is a Kirchhoff's law. Ohm's law is precisely conductance multiplied by input voltage magnitude. So that analog computation is achieving high computational speed as well as power reduction. So it's all connected. So in a sense, in AI, analog is playing very important role, for which circuit theory, nonlinear circuit theory is very, very important. So in my view, a lot of things, the more you know, the more you can connect actually. So for which circuit theory is very fundamental, system theory is very, very fundamental. If you add some device knowledge, you can do a lot.
Yeah, in-memory computing is also becoming one of the major areas now, and there memristors can play a role. It's not fully developed, but many people are working on it.
Yeah. So when I worked with Leon Chua, that time, my master thesis at the SUNY Buffalo was on the Hodgkin-Huxley equation, actually bioengineering I was interested in at the time. So when I worked with Leon Chua on modeling of nonlinear devices, we identified Hodgkin-Huxley's ionic channel being memristic. And then if you look at neuromorphic computing these days, all this synapses is precisely memristor. So in my view, is theory and the practice is connected together in a beautiful way. So I encourage all the students and younger generation, learn in depth about fundamental theory of although time is limited, but then you can really have a new breakthrough and a lot of new inventions.
Very much so, Steve. If I can add, I just remember Alan Wilson's comments. There is no separate theory and practice. They come together. And so I
Right.
remember him saying that you cannot just do theory and practice separately, because that's why theoretical background is still very important and very important part of our engineering education.
Yeah, so when I was a graduate student, the Charlie Tissot was my academic advisor. And then when I went to see him on his door, this is, I quote, in science, self-satisfaction is death. Personal self-satisfaction is the death of the scientist. Collective self-satisfaction is the death of the research. It is restlessness, anxiety, dissatisfaction, agony of mind that nourishes science. It turns out that was the quote from Jacques Monod, who got Nobel Prize in Physiology in France. But that was Professor Charlie Tissot's motto to his graduate students. I forever cherish that. So it's just an endless, continuous effort to improve. I think that is important. And the technology will change, but we can try a lot of different things, and there will be. People used to say, "Oh, all the research is done." That's not true. A lot of new things are developed continuously. So this is message for younger generation. You can do a lot. I think future is even more exciting than what has been until now.
That's very true, very well articulated, and I think Vijay and Lajana for pouring in your comments that whatever we did was great, but a huge, I would say, a huge scope, and its future is still much brighter than what we assumed many decades back, when all you great leaders, when you guys signed up and started contributing in the circuit systems field. We have set a question, but we are already out of time. Out of the budget time, 3 minutes overdue, and I will ask Samantha to consolidate these questions, and maybe over the email we can get back to you with the answers. So thank you so much, all three of you, the great leaders, being part of this interesting, I would say, a precious, valuable, discussion, sharing your thoughts, your views, your rich experience about all the great contribution to circuit system society, and all the great initiatives which got started with you are still benefiting the society and the all the members at a larger scale. So with this, I'll call it as a close. We are already overdue with the budget time, and thank you so much for all the great participants. Being part of such a great discussion for this session. And I'm sorry, in the interest of time, we'll be not be able to call out all of your questions. Those few of those questions were already covered part of the discussion during the session today. But we can collect those questions, and we'll work with the IEEE CAS management team, and get back to you with these answers. So again, a big shout out, a big thanks to all the three panelists, Steve, Lajana, and Megan, and looking forward to have a more productive session. And I am sure with all the good mentorship and guidance with all of you expert, society is gonna grow multifold. We already celebrated 75th year, and I'm equally excited to have you guys still around, working on this technological affairs when we'll celebrate 100 years of Circuit System Society. So with this, I'll close this session. Thank you so much to the panelists. Thank you so much to the participant. Big thanks to IEEE Circuit System Society for organizing this webinar. And this all the Q&A remaining questions would be answered over the email. Thank you. Have a great day.
Thank you.
Thank you very much.
Thank you very
Bye-bye.
much. And thank you for
Bye-bye.
Thank you, sir.
to the participants.
Thank you
Bye-bye.
so much, sir.
Thank you.
Thanks. Bye-bye.